Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Roslan and my teammate was Nik Shafiq Haikal bin Ismail. In this presentation, we like to present about the spectral reflectance in the measuring crop nutrients. First of all, let's we move to the table of content, which is introduction, content, discussion, conclusion, and recommendation, and lastly the reference. Moving on the introduction, remote sensing is the science and art of obtaining information about an object, area, or phenomenon through the analysis of data that been collected by a device. In remote sensing, there are several components that have been involved, such as energy source or illuminations, radiation, and the atmosphere that interact with the target, recording of energy by the sensor, transmission, reception, and processing, interpreting and analysis, and lastly, application. For this presentation, we like to present about the spectral reflectance from a plant canopy depend on the interaction of electromagnetic radiation with the biophysical and the physiological parameter, and hence contain the large amount of information. For your information, a spectral response of vegetation depend on the structure of the plant leaf. The diagnostic method like remote sensing technique that take advantage to the optical properties of the leaf are another possibility to assess the nutrient status of the plants, especially larger spatial scale. Remote sensing also could provide inexpensive large area estimate of crop growth condition and can be used to monitor nutrition and other stresses, utilizing the information containing in the spectral reflectance data. Various technology has been used to exploit the basic relationships such as color infrared films, digital camera, multispectral sensor on airplane and satellites, and handheld sensor measure the light in narrow waveband, which is wavelength interval. And for your information also, the plant reflectance measurement through the remote sensing has been used to qualify the canopy vigor as well as the nutrient and water content or the water availability of the plant. What is a spectral signature? The radiation reflected as function of the wavelength is called as a spectral signature of the surface. Different in the reflectance were also observed in the part of NIR, which is a near infrared, and the SWIR, which is a short wavelength infrared. The difference was NIR for the detecting or reflecting the characteristic of the leaf structure. Meanwhile, the SWIR is to observe the water availability and the water content of the plant. As you can see for the picture below, this is the graph of the spectral observation, which is this spectral measurement has been divided into three component, which is visible, nearly infrared, and shortwave infrared. As you can see, the first one is visible. Visible is we can measure the number of the chlorophyll of the plant. To measure it, the plant was absorb the spectrum light from the sun, which is we determine if the plant was stressed or not. And for the second one is near infrared or NIR, which is the reflectance due to the spongy mesophyll. In this phase, we can detect whether the plant is nutrient deficiency or the plant has a disease. And the last one is the short wave infrared, which is SWIR, is the phase on we observing the water content of and the water availability that the plant show. Precision agriculture and edges relating to the spectral or on measuring the crop nutrients. The use of remote sensing in PA is influenced by the types of platforms such as satellite, air, and ground. To collect data collections, a number and a wide of spectral bands captured by the sensor, whether it's a multi or hyperspectral, spatial, which is high, medium, and low, temporals, which is hourly, daily, or weekly, and radiometer, which is 8, 12, and 16 byte resolution of a sensor from the collected the data. And how does the precision and edges do? First, getting accurately the image mesh the ground on the ground location, which is we call it a geometric precision. And second, it extend the image the speed feature in the grounds, which is we known as spectral resolution. And lastly, accurate image by the quality spectral information, which is the phase that the information has been extracted to some kind of data that we can be observed, whether it's the plant was nutrient deficiency, stress, or has disease. So you can see the picture was discussed about the quality of the remote sense imagery. First is a geometric precision, which is a sensor position, global position, system, and view angle. Second is a spatial resolution, sensor position and viewing angle. And third one is a spectral resolution, which observes the wavelength interval band in the electromagnetic spectrum. And next is a temporal resolution, which is a combination of frequency image acquisitions. And the fourth one or the fifth one is a radiometric resolution, which is a number of bytes used by a sensor to create informative data that can be understand. And lastly, a spectral information is atmospheric absorptions, atmospheric scattering, cloud condition, and sun position, which is the environment or the surrounding picture of all the information. That's all for me, and I would like to pass the baton for my teammates to continue about the discussion, conclusion, recommendation, and also reference.
Thank you, Muhammad Firdaus. Assalamualaikum warahmatullahi wabarakatuh. My name is Nishifaika bin Ismail, and now I will continue the presentation. As my friend explained earlier, a spectral reflectance is a measure of the fraction of light of a specific wavelength that is reflected by a surface or material. It is typically measured over a range of wavelength, and the resulting data is often presented as a graph or curve. Spectral reflectance can be used to determine the color and texture of a surface, as well as to identify and quantify various materials such as mineral or pigment in artworks. As we all know, nitrogen, phosphorus, and potassium are one of the major nutrients needed for a crop in order to stay healthy and alive. These nutrients are called as macronutrients. The nutrient in plants such as the nitrogen can be detected by using spectral reflectance through the chlorophyll content in leaf. The chlorophyll strongly absorbs light at wavelength around 0.45 for blue and 0.67 micrometer for red, and reflects strongly in green light. Therefore, our eyes can see a healthy vegetation as a green. If we give the nitrogen fertilizer to the crop, it will provide protein and protoplasm, which are used to improve growth and reproduction, and also assisting the leaf to have a deep green color, especially in vegetable. So what happens if the plant is stressed? When the plant is stressed, the chlorophyll content in leaf will be decreasing, causing the leaf to absorb less chlorophyll absorption, which can lead the leaf turning to yellowish. When the leaf are turning yellowish, it will show a higher reflectance, especially in the red region. A study had been made by Luis Joel Martinez in 2017 about a comparative study for nitrogen content in plants between dry and rainy season. A few types of crops such as rice, oil palm, soybean, rubber, and maize had been studied by the researcher for the nitrogen content in plant between dry and rainy season. Based on the result from the study, it shows that there was a higher reflectance in the visible range of spectrum for dry season compared to the wet season, because the plant were generally less green with a lower moisture content and with less chlorophyll, leading to lower energy absorption and showing greater reflection. The dry season had causing the crops to become more stressed compared to rainy season. Based on the example picture, we can see there are three types of color, which are the green, red, and yellow. Okay, the green color indicates that the crops are growing healthily. Meanwhile, for yellow and red in color indicates that the crop are facing stress, causing the nitrogen content in plant are reduced and showing a higher reflectance for spectral reflectance. There are a few different ways that spectral reflectance can be measured and reported depending on the application and the equipment available. Here are a few recommendations for measuring using spectral reflectance. The first recommendation is calibrate the equipment. Before measuring the crop nutrient content using spectral reflectance, it is important to calibrate the method using ground truth data obtained through the traditional methods such as soil and leaf sample. This will ensure that the measurements are accurate and consistent. The second recommendation is use the appropriate equipment. Spectral reflectance measurement should be taken using appropriate equipment such as spectrophometer and hypercentral sensor that can measure reflectance over a wide range of wavelength, typically from the ultraviolet to the near infrared or NIR. Third, measure reflectance at different growth stage. The reflectance can be vary depending on the growth stage of the crop, so it is recommended to measure the resistance at different growth stage in order to obtain a more accurate representation of crop nutrients content. Fourth recommendation is measure the reflectance at multiple angles. The reflectance can be vary depending on the angle at which light strike at the surface. Therefore, recommended to measure reflectance at multiple angles in order to obtain a more accurate representation of the surface. And lastly, validate the result. The result obtained from the spectral reflectance should be validated with the traditional method, such as the soil and leaf sample, in order to ensure that the results are more accurate and significant to each other. Okay, lastly, in conclusion, the spectral reflectance is a useful tool for measuring crop nutrient content. By analyzing the light reflected by plants at various wavelengths, it is possible to infer the nutrient content of the crop, such as nitrogen, phosphorus, and potassium. Reflectance at specific wavelength can also be used to infer specific nutrient content. These methods are non-destructive, rapid, and cost-effective. However, it is important to note that this method requires calibration using ground truth data obtained through the traditional methods such as soil and leaf sample for accurate results. Spectral reflectance can be used to monitor the crop health, detect nutrient deficiency, and optimize fertilization practices with faster and time saving. Okay, this is our references. Okay, that's all from us. Thank you for watching.